Hey everyone, we're going to take our class notes on 12.2, day 2, so still working with radicals. Today we're going to be dividing them again, which we also did in 9.2, but today's dividing, we're going to see that what's in the bottom is not perfect. So we're going to learn what do we do when it's not perfect, because all of the ones that we have done in 9.2 were either perfect or we could reduce. This number's outside, not under, no reducing can happen. Outside, not under, no reducing can happen. So we have to keep working through this because remember the steps for simplifying say that you can't have a root in the bottom. And so to remove the root from the bottom, that's why this is not simplified. So your directions are just to simplify all of these. We have to make it perfect. If it's perfect, it can come out and we won't have a jail anymore. We won't have a root. So I'm going to multiply the top and bottom of this problem by a root that's going to make this one perfect. And so it makes sense to me to use 3. I want to get one of these numbers. 3 times 3 will get me 9. So I'm going to use root 3 times itself. 3 times 3 is 9. Now that becomes perfect. So in the top, 2 times root 3, outside, under, keep it outside, keep it under, that becomes 2 root 3. Both under, we multiply 3 times 3 to get 9. Again, 9 is perfect, so now it can come out of the jail as 3. So I still have a 2 root 3 in the top, but in the bottom I have a 3. Now these are both outside, so no reducing here, but you could try to reduce here. These numbers are both outside. No radical, no root. We can't reduce 2/3, so it's just going to stay 2/3 times root 3 or 2 root 3 over 3, however you want to say that. Next example. Again, 7 is not perfect. There's no perfect that goes into it. I want to go ahead and get this out of the bottom. I can't have a root in the bottom, so I'm going to multiply the top and bottom by a number that's going to make this perfect, which ends up being itself. 7 times 7 is 49, and 49 is on our list. So I'm going to do root 7 to the top and bottom. What you multiply to the bottom, you have to multiply to the top. So when I multiply these, I just get 8 root 7 because the 8 is on the outside, it's not under a root, and this is under the root. So you can't do the 8 times the 7, but you can show it as 8 times root 7. Now we can multiply the 7 and the 7 because these are both under and in jail. And when we multiply 7 times 7, we get 49. And 49 is on our list and will come out as just a 7. This is perfect. Perfects come out. This is not perfect. It stays in jail. Out, out. Can you reduce those? No, you cannot. Final answer. Next example. I would suggest, I see 24. It's a pretty big number. I would suggest trying to simplify that first, in my opinion. And so I'm trying to see if 16, 9, or 4 go into 24 evenly. These all go into 24, but which one goes into it evenly? And the answer is 4. So I'm going to start by writing this as keep the 4 in the top. Changing the 24 into, I always like to put the perfect first. So I'm going to write that as 4 times 6. Okay, so perfect, not perfect. 4 stays in the top. 4 comes out as 2. 6, stays in the jail. 2 root 6. Now if you want, these are outside, and if you wanted to reduce at this point, you could. 2 goes into 4 2 times. So I get 2 over root 6. Now root 6 can't be simplified. 6 is not perfect. So I'm going to go ahead and multiply the top and bottom by root 6 so that I can create a perfect square here. In the top, I'm going to get 2 root 6. In the bottom, I'm going to get root 36. Perfect, not perfect. 2 root 6 is staying. 36 will come out, no jail necessary, and you get a 6. 2 and 6 are outside, so we can do some more reducing. 2 goes into 6 3 times. So I end up with a root 6 in the top and a 3 in the bottom. Now we can't simplify here because this is in jail, this is under the root, and this is outside. There is no root, there is no jail there. Final answer. Last example. 5 is not perfect. There's no perfect that goes into 5. So I'm just going to go ahead and multiply the top and bottom by root 5. Why am I doing this again? Because I shouldn't have a root in the bottom of a fraction. No root. That was one of our steps that we wrote down in 9.2 for simplifying. No root in the bottom. So we need to get rid of that radical. We do that by multiplying a radical by itself. 3 times root 5 is going to be 3 root 5. 3 is outside, 5 is under. We just show them multiplied next to each other. These are both under, so we can multiply to get 25. And 25 is perfect. So it's going to come out, and we're not going to have a jail anymore, and that's what we don't want. We want in the bottom no root. Simplified form says no perfect that goes into your radicand, no radicand as a fraction, and no root in the bottom of a fraction. Now 3 and 5 are outside. Can we reduce those? No. Final answer. Have a great day, everyone.